Hello YouTube, RJ. Hey, I know it's been almost a month since I did a video. Had some family emergencies come up and I had to deal with them. So didn't have time to be in the lab much. Sorry about that, but family's always going to come first. So anyway, I'm back in the lab today. Going to be a real short little video. What I'm going to do today is, one of the things is, if you were with me back 10 months ago, I was working on pimping out my new HP frequency counter. And I put that high stability oven in there, and I said, hey, I'm going to cook this thing in for a couple of weeks and come back and we'll calibrate it, and we'll see, then we'll let it run for a long time and we'll see how stable it is, how well it does. And so, well, gee, that's been 10 months ago. So I'm finally getting around to it. So here's the deal. It's been cooking in for 10 months. The oven is on even when the meter's off. It's been running continuously, so we know it's really cooked in. But so I had a thought, I haven't even checked to see how much it's drifted. So let's do this before we calibrate it and give it a while to check. We calibrated it 10 months ago, hadn't cooked in much. It might have had a few days of cooking in at most. So I thought it'd be cool to go ahead and just check it right off the bat and see in 10 months, how much did this thing drift? We calibrated it to my GPS DO from the atomic clocks on the satellites. I can literally feed that GPS DO in, knowing that it was going to be very close, and see how close it's reading to 10 megahertz, and we'll know how much it's drifted, because that's what it was calibrated to. You will get a little drift with the GPS DO, but not much, because it's constantly being updated. So it should be pretty close to right on there. So what I did is I went ahead and I turned the counter on. I've let it warm up for about, 3.5 hours maybe. And I haven't connected anything up to it. I set it to be the internal reference, so it's running off of the high precision when we calibrate it. And I've got my GPS DO cable here connected onto it, and I thought we would just hook it up. I went ahead and set it up for a long gate time. I'm running 10 seconds gate. That way I get a lot of digits, we get a lot of averaging, we get a smooth reading and get a very precise reading. So I thought we'd go ahead and check it out. So let me pull my little cap off here. Let's hook this up, and if all is well, we should get a reading off this thing after a while. So how close do you think it's going to be? I don't know, a few hertz off maybe? We'll see. Wow. Holy smokes. Okay, I stand corrected. It is a lot more stable than I thought. I would have thought this oven, not having been cooked in very much, would be off more than this. But as you can see, what am I? 76 millihertz, 27 millihertz, or 77 millihertz. Wow. I would have thought this thing would have drifted over 10 months a lot more than that. That's pretty stable. Let's go ahead and calibrate this thing to the GPS DO again and get it right on. And then I'll let this thing just run for, let's say 3 days. I'll let it run for 3 days and we'll see how close it's staying. So let's go ahead and do that right now. So what we have to do is we're going to come over here, and let me remember to do that. We have to, I think we have to turn it off, hold this and turn it on. Yeah, that's what I thought. It's been a while. Oh. Help of a Kyle unsecure, I think, actually. Yeah. It's been 10 months. I have to kind of remember. Okay, here's our time base. That's what I want to do. Enter. Okay, now it's going to ask me to supply 10 megahertz, which I'm doing from the GPS DO into channel 1. It's going to tell me to hit enter, and then it's going to take a little bit. Okay, it's done calibrating, so we should be able to hit run. And let's change our gate back to It's been a while, guys. Hang with me. Let's go back and put it back to 10 seconds. Okay, you have to hit enter. We'll say run, and we should get a 10-second gate now. Okay, pretty good. 1.3 millihertz. That's, I'm gonna say it's close enough. 1.2, pretty close. Let's just remember that. Roll around 1.2, 1.4. Let's let this thing roll for 3 days. I'll come back, and of course for you it'll be, well, we're back. It's been 3 days. Let's take a quick look at our frequency counter. And well, you know, this drifty old terrible thing that tracks off so much has changed about 1 millihertz. So not even quite that, actually. So we're still on a 10-second gate, and it's fluctuating a little, but bear in mind the GPS DO is not absolutely perfect. They drift a tiny bit, but you can see that, you know, we're within a millihertz or less on a 10 megahertz signal. So, hey, I'm gonna take that as this thing is really, really good. Man, I wish I could build VFOs this good. Could you imagine if we could build VFOs this stable, easily and cheaply for our ham radios? Wow. So anyway, there you go. That's the answer we've been looking for. My aftermarket high stability oven oscillator for my 53131A works very, very well after a good cook-in. In fact, there we are. We're only a couple tenths of a millihertz away from where we were. Looks like it's going to bounce up close to where we were when we calibrated it 3 days ago. Considering we were only like 70 something millihertz off after 10 months, yeah, I'd say it's doing pretty good. So hey, thanks for tuning in. Hope see you in the next video. We're going to get back on the voltage calibrator and get some more work done there. We're going to talk about some of the circuitry and a safety concern I had with it and how I'm going to rectify that. So hopefully you'll tune in to check that out. So thanks for hanging in with me, and I'll see you in the next video.